Good morning. How's everybody doing? Hopefully you guys got enough sleep last night. The storms didn't keep you up too much as we went into late last night. Pretty loud. Did you get any lightning? How about thunder? Hail. Did you get any hail? Let me know if you can hear me. Hopefully you can, and we'll get things started off. I'll get everything logged on here on the other computer. Today we've been talking, this is week number 3 of the Getting Schooled series here, and we've been talking all about weather, of course, severe weather, the first week. And, you know, it's interesting how the weather has kind of played out. We had a lot of weather last night that we've talked a lot about in recent days. We had the lightning, we've had the rain. There's a lot to look on radar. Hail. There wasn't, thankfully, any tornadoes in our area, but the ingredients were right for a tornado or two if we would have had the right type of storm set up. Instead of a line of storms, we would have had little clusters of storms start to rotate. It could have helped produce that. So a lot of interesting weather has been taking place, and we can hear and we can see more here as we head into tonight. Just a few storms, and then it gets really cold starting for tomorrow. All right, so we'll get started here. We're going to talk all about weather observations today. So earlier this week, we talked about radar. We talked about satellite, how important those tools are. Yesterday, we talked about the computer models. I don't know if anybody has gotten a chance to kind of look at those computer models on your own on that website that it gave you yesterday, but that is certainly always there for you too. So let's get right into it. This is Getting Schooled, and if you're just joining us for the first time, we are talking all about basically how the weather works and why it works the way it does and the science behind it. And we're all kind of leading into learning how to forecast. So this week we've been talking about a lot about those weather tools and how important they are to help you forecast, and we're going to do that again today. So today we're talking about observations and weather balloons and why they're so important. Next week we are going to be focusing a lot on forecasting. So Monday is all about clouds, because clouds, the type of clouds that are out there, can tell you, they can give you hints on what the weather is going to do. So we'll talk all about that. On Tuesday we'll talk about fronts and why we get so much rain and snow along fronts, what low and high pressure has to do with it. And we'll talk a little bit about, we'll start to go through some forecasting exercises on our own. And then on Wednesday, I'm going to give you guys some of the same weather data that I'm looking at in the morning. So whatever's happening next week on Wednesday, we'll look at all that stuff. And I'm going to have you guys put your first forecast together. And then the following week, we'll come back and we'll see how everybody did. So let's get right into it. We'll talk about the forecasting tools, and there's a lot that helps us out. And I've talked about this a little bit already. If you're going to put a birdhouse together or you're going to build something, there are going to be some tools that you're going to want that are going to help you out. Maybe it's a hammer. Maybe you need some supplies like nails or glue to put that together. Wood might be helpful. A screwdriver could be helpful. So all of those certainly can be helpful for us. But this is a look at some of our forecasting tools that we've got. And down here on the bottom of the screen here, this is a fancy looking barometer. Now, I don't have a barometer like this, but this would be really cool if we did. This is kind of an old school one where the air pressure is going up and it's going down, and it's actually creating a line graph on this spool here that goes around very, very slowly. And you can kind of see not only where the air pressure is now, but where it has been in the past. So that's kind of neat. Kind of an old school barometer there. Now we've got a lot of electronic ones. Thermometer, really important. That measures the temperature. And then up here, we've got a wind vane. You see these little cups here. They collect the wind, they spin around. And based off of how quickly they spin around, there's a little sensor in there that measures, okay, we had to spin around 8 times in 1 minute. And it is able to calculate what that means when it comes to the wind. So the wind moves into these little cups and it pushes it around and around and around. And this over here is a wind vane. So it's going to let us know what direction the winds are coming from. So what direction the winds are coming from, how fast the winds are going. We've got barometer for air pressure. And then over here, we've got these weather maps. And I showed you a bunch of weather maps yesterday that help us out with computer models, but we also look at current weather maps too. And in this case, you've got, which we'll talk more about next week, you've got your cold front here, you got your warm front, and then you've got your low pressure right in the middle of that. I don't see any high pressure on this map, although there is some higher pressure up in here, up into parts of Canada. Another low pressure out towards the southwest, and some more fronts. And then you can see the clouds, you can see some rain, and a lot of times they're close to the fronts. But these are all tools that help us to put a forecast together. quite a bit whenever we're dealing with that. So we look at the currents, we look at satellite, we look at radar, like we've talked about already, we look at our computer models, but we have to know what's happening right now, or else we're never going to be able to figure out what's going to happen in the future. So outside right now, who can tell me what the weather's doing? Let me know here. Have you looked outside so far today? We're going to be talking all about observations. So let's start right now. I'll pull up the latest here. Let me know what's happening outside. What do you have outside? Do you have clouds? Do you have sunshine? Is it warm? Is it cold? Is it windy? Let me know here. I'm going to see. There's a little bit of a delay, so I'll wait for your answers to come in. Let's see. I'm just waiting for some of those comments. So what's the weather doing at your place right now? Sunshine and calm in Monroe. That's what I've got here too, William. It's nice and sunny. It's warm. We've got our temperatures in the background. So I'm looking at 58 in Monroe, 59 in Toledo, 62 degrees in Findlay. Sunny in Findlay, so looking good. A little bit windy, cloudy, warm. That's back into parts of Indiana. Cloudy, and Jill says cloudy. Yeah, so we've had some clouds this morning, so trying to push on out. Sandusky's much cooler. I'm going to guess we've got some clouds out towards the lakeshore. A little breezy, sunny and calm in Toledo. So yeah, so these are all good. This is all really important because we can't put, well, we can put a forecast together, I suppose, but we're not going to be able to put an accurate forecast together unless we can be able to see what's happening right now with the weather and then take those current conditions kind of moving forward. Courtney says super sunny. Yeah, you bet. Ed in Perrysburg saying warm and sunny. So this morning when I walked out, it looked almost like it was sunny in the middle of the night because that big supermoon came out between the clouds and it was bright after those storms moved through. It was bright when the storms were moving through too with all the lightning last night, but much calmer on the backside of this. So let's go ahead and take a look at what else we're dealing with. And weather balloons, and this is so important. This has been around, oh my goodness, almost good 90 years, almost 100 years now. And this has been one of the key ways of forecasting the weather. Why is a weather balloon important? We can measure observations all we want at the ground. Well, this thing is going to go up into the sky. Look how big that weather balloon is. It's about as big as he is putting it together. And they've got a little flag on it here. Now, what you can't see is what he's holding kind of right in there, close to where his arm's coming together. He's got a little box that measures all of that weather data. And that is what is so, so important here. And I've got a close-up look at what that looks like. Here's the little box, and it is a little box because it's just kind of will hold in your hand. This is kind of a blown-up picture of it. But inside here, we have all these little weather instruments, and it's going to measure all that information and do it quickly as that balloon's going straight up. So I've got a video. I love weather balloon launches. I think they're so cool. And what's even better is all the data that comes back from it. But this is something that isn't automatic. Forecasters have to do this every single day when they get to the station. Usually it's done at 7 a.m. or 8 a.m., depending on the time of the year it is, and also 7 or 8 p.m. So it's done twice a day. So I'm going to show you this video here. And this is, you're going to also see some captions at the bottom of your screen, but what you're looking at is you're looking at a meteorologist working for the National Weather Service. This is in New York, and this is a nice, nice day. You can see the sunshine here, and they're going to get a balloon launch together. So this building right here is built just for weather balloon launches. And I've been able to go up to the Detroit Weather Service a few times when they've done this and launched these balloons, but it's really neat. So they put it full of helium, and look how it starts off. This is a weather balloon, folks. I've got a red one. She's got a white one. And it's already kind of big, right? I mean, it can kind of cover my face up here. But as this expands, I mean, it can really, really expand. Now, I've had this for like almost 20 years, maybe a little over 20 years. So maybe this won't expand out as much as what it used to. But it certainly can get really, really large. And here's the thing. It gets even bigger the farther up it goes because that pressure that's inside the balloon just keeps pushing it out and out and out, and eventually the balloon pops, but it has to get really far up there first. So, okay, so they've got they're making sure that all the weather data, those little weather instruments that are inside that box, they're making sure they're accurate before they ever let it go up. So they're testing it to make sure it's accurate. They've got the balloon. They're starting to fill that up with some helium. And they attached a little flag to it. They got the string, and she's going to hold that box in her hand, or he is right there. So that box that goes up, that's going to be the weather instruments. And there it goes. And it goes up pretty quickly. And here's the thing about these weather balloons that are so neat. They're going to go wherever the air takes them. And that's kind of the point. They're measuring the wind. And so it might start to go up one direction, and then it might turn another direction, and then come back. Sometimes these weather balloons will go straight up into the sky, and if there's not much wind, they pop and come back down in a similar spot. Sometimes in Detroit, a lot of times they end up in Canada because the winds will push them into Canada. Sometimes they end up in Lake Erie. But they do have a little message on the box. So if you ever see a weather balloon that pops and it's in, say, your front yard or something like that, there's instruments on how to get that back to the National Weather Service. So that's so important. That it happens at almost 60 spots around the country twice a day. That data is the only weather data that we're going to get that's really high up on in the sky. We need that to put an accurate forecast together. Other things that can help us out is satellite. We talked about that. And also airplanes. Now, airplanes aren't flying as much right now during this whole period that we're going through because people aren't traveling around a whole lot. But those weather instruments that are on the airplanes give forecasters valuable information that actually help. All that data then goes into the computer models, and the computer models help forecasters figure out how the weather is going to change with time. So it's all really, really important. Also, if you may have some of this stuff at home, you may not, but I thought I would share it with you before we talk about some of the weather instruments I've got here and how to do your observations at home. But if you want, and you've got the materials at home, you don't need to go out and buy stuff for this. You don't need to make a trip out for it. But you can build your own barometer at home. So if you've got a pencil, a straw, maybe a spool, some paper of some sort that says marked with an index card with tape. You can do that, but you can improvise too. A balloon, although you don't need a big weather balloon like this. A normal balloon will do just fine. And then a glass, and I think we probably all have that at home. And if you put these things together, kind of like this, so you've got the glass, you put the balloon, you cut the balloon and stretch that over the glass. So basically you're trapping the air that's inside of it. And then if you take a straw, toothpick or sewing needle, kind of on the end of that. Our little spool and our pencil, we're basically just making a little sign here with our card. And so we want that card to be up there, and then that pencil kind of goes over it, kind of in the middle, and you can mark it as such. Now what happens with time is that if the air pressure goes up or goes down, the air that is trapped inside of that bottle there, or in that glass, it's going to fluctuate. So it's going to go up or down a little bit on that balloon. I don't know if anybody has ever had like a can of Pringles or something like that, and they've gone on vacation and then they've opened it up. Maybe you've gone into the mountains or somewhere, and or even a bag of potato chips or something like that was sealed, and all of a sudden you open it up and poof, all this air comes out and it's kind of bulging already. That's at high. The pressure that is changing inside of that, whether it's the lower pressure or high pressure, it is going to either essentially put pressure on the bag, or the air inside of the bag is going to put pressure on the outside. And so that's basically what's happening here. And so if you put all this stuff together, then if the air pressure goes down, well, then there's actually that lower pressure means that the pressure inside that jar is going to expand. It's going to tilt the needle down, so you know it's a lower pressure. And if it goes up, that means you've got some higher pressure. And why does that matter? Well, usually when it's sunny out, you have higher pressure that's coming in, and cloudy and rainy and snowy, usually you have lower pressure around for that. So when it comes to weather instruments, I brought just a few that are some of my favorites that I have at home. And this one is an older one that I've got, and but I just think it's so neat. Remember I showed you the anemometer, the little cups that go around? Well, these are the little cups here, and I'll try to get this right up next to the camera as best I can. And You can see this is kind of like a little box that goes on the weather balloons that we were talking about. But this little display here, if it goes really, really far up, this needle will start to go up and tell us how fast the winds are. So that's nice, and I like it. It's kind of an old school one. But then I've got another one over here, and it's kind of the same thing, but this is electronic. And these little tiny blades inside of here, when the air turns them around, does the same thing. And then here's my little display. I can blow right in it, and you can see the display goes up and goes back down. Let's see. Oh, I've got it on max. So apparently I've got a lot of wind. That was a 40-mile-per-hour wind gust that I just made. Take a look at that. By the way, that's basically what Mother Nature is going to provide tomorrow. We'll get a lot of cold, a lot of wind, maybe some 40-mile-per-hour wind gusts. This over here is an electronic thermometer. It's also got a spot to measure wind. It's got humidity. It does have barometer on here too, which is the same thing that we were showing that you guys can make at home. If you've got a balloon, a glass, some straw, some paper, that type of thing, measures air pressure, and it can help you to get an idea. If the air pressure goes down, that usually means clouds and rain are trying to move in, maybe in the next 24 to 36 hours, next day or two. So that can be a useful tool to help forecast the weather. So I showed you the big weather balloon. I don't really do much with this at home. I just think it's neat. And then the other weather instrument that I've got over here, which got a big workout last night, but this is a little small lightning detector, which lightning sends out a frequency, a little pulse of energy that can be picked up and detected. And right now it's listening. It's trying to listen for anything. Of course, we don't have any lightning around the area, so I'm going to go ahead and turn this off. But it would beep and it would light up and it would tell me how far away the lightning is if there's anything. And here's something that's pretty neat. You already have access to a lightning detector, but you probably don't realize it. It's called the AM radio, not the FM side, not streaming, not Wi-Fi or something like that where you're just going to get some music or even a CD. But this is the AM radio, something that many of us still have in our cars, or maybe you can find it somewhere. If you turn it to those lower frequencies, right around 600 or something like that, find a station, or find a frequency where there is no station, where it's just fuzz. And then when you get into a lightning storm, you can hear lightning sometimes 100 miles away. It'll come in and it'll psh, psh. You'll hear different types of static pops and all kinds of stuff. And you can actually many times hear lightning that's 100 miles away and get an idea what's happening before the storms even get to you. So that's pretty neat. We'll go ahead and get to, well, first of all, coming up now as we go through the next several days. So here's your homework assignment. If you've got a thermometer, great. If you've got a rain gauge, fantastic. Even if you don't have those things, kind of like we were just doing earlier today, I want you to write down on a piece of paper. So today, Wednesday, we've got Thursday, Friday, Saturday, Sunday. As we go into the weekend, the next several days, all the way until Monday of next week, just write down what the weather's doing outside. If you've got a thermometer, write down the temperature. That's fine. If you've got other weather instruments at your home and you can write down even more, like the barometer and all that, that's great too. If you can just write down if it's sunny or cloudy outside, if it's cool or warm or windy, that all works. I just want you guys writing down what the weather's doing outside, which you guys observe with your own eyes, and we'll take that into next week and we'll start to take that to help forecast. So I'm going to get to the questions now. Any questions that you guys have, weather balloons, weather observing, maybe it's something about the storms last night. I'll leave it up to you guys for all those questions, and we'll go from there. Remember, next week we'll have those observations, try to do that every single day. Take a picture of them, send them to me, have your mom or dad send them to me, and I'd love to see that, especially as we get into early next week. When you get those sheets done, and by that point you'll have several days lined up, and it'll be a lot of fun getting into the forecasting part of it next week, which will be a lot of fun. All right, so let's go ahead here with any questions here that we've got. All right, so first one, Emily asking, are weather balloons similar to hot air balloons? Yes, other than you don't want a hot air balloon to pop. The whole point is eventually the weather balloon will get so high, it'll stretch so far that it's going to pop. So right now this weather balloon takes up the size of my face. Eventually it'll be like the size of a car, and eventually it'll get so thin and it'll pop. and then it'll fall back down to earth, and so it does a good job on that. Hot air balloons, too, go wherever the wind takes them. So in that way, they are very similar. Hot air balloon, you can't get in it and say, okay, I want to go that way, and then I want to turn around and go that way. That's not how they work. It can, depending on how much hot air you put in them, they can either go up pretty quickly, or if you shoot cold air into them or not very much hot air, they come back down. That's about the only control they have over them. Again, you don't want them to pop. That would be really bad. Let's see. How do they work with aviation with a weather balloon? So they're not really too much of a concern when it comes to airplanes for the most part. Once they get up to about the spot where airplanes are flying, a little above that point is usually where they pop and they fall back down. So pilots, they can spot these. Now, with that said, before these are launched off, the National Weather Service will make sure that everything is clear, they're good to go. They do a visible look around and everything else to make sure that they don't have incoming planes or anything like that. So it's not so much of a concern when the when the weather balloon gets up really high into the sky. It is a little more of a concern when it's a little bit lower, and they do make sure that, okay, we don't have anything around the area that's going to interfere. So good question there, Walter, asking that one. Ron, difference between partly sunny and partly cloudy. That's a good question, and you know, honestly, there's not much of a difference there at all. Some meteorologists will just use partly sunny during the day and partly cloudy at night to try to differentiate that way. Some other meteorologists, including myself, will kind of break it down from, on a scale, you've got sunny being the most sunshine. There's about 80 to 100% of the sky. Actually, we say about 90 to 100% of the sky. Mostly sunny, you're looking at 70, 80 to 90% of the sky is sunny. Partly cloudy would be the next category, so still the majority of the sky is sunshine, but partly cloudy, it means about 60% of the sky is sunny. Partly sunny would be about 40–50% of the sky, and then mostly cloudy, usually about 20% of the sky is sunny, 80% is clouds, and then cloudy, totally overcast is 100% clouds is usually how we go about that. How do you make the pressure gauge again? So let me go back, Ben, on that. And so I will, here are the materials. I mean, the biggest thing is that you're going to need a glass and a balloon. So if you've got those two materials, I think you can improvise and make this work. So basically, you're going to take that glass as the first thing, and you've got that balloon, and you're going to essentially cut the balloon out a little bit and stretch it over that glass. So depending on what kind of glass we have, that may be easy or may be challenging, but that's really what is driving this. You're trapping the air that's in that glass, and then you're putting a straw or something light on it that that can easily be fluctuated by something that's on there. You don't want something too heavy. That's why they have a straw that's on there. Honestly, the needle or the toothpick or whatever, if you've got that and you can tape it on the end, great. If not, I don't think it's really that big of a deal. You're still going to see it move around. And then they kind of got cute here with the thread spool and the pencil and the sign. The pencil's a good idea, but as long as you have something to stand it up and you're putting that needle or that straw, whatever that is, kind of in the middle of that sign there, that way when the pressure does change on that inside the glass and it moves basically that balloon up or down, and then it moves the straw as a result, you kind of get an idea of where things are going. So, and again, high pressure on this would be hot, would be up, and low pressure would be lower. So that's what the H and L stands for there. Let's see. What is your favorite part about being a meteorologist? I think my favorite part about being a meteorologist is that everything is different. So today, for example, it's sunny and we're going to be in the 70s. Yesterday it was sunny and we were in the 70s. So how is that different? There's a lot that's different behind the scenes on getting us to that result, and it's going to have a big difference on what's going to happen tonight. So yesterday we had high humidity and we had the warm weather and the sunshine and all of that, but that high humidity and also the approaching upper level wave that we had was, and those winds that were coming from the basically bad direction, we had the wind shear in place, all those ingredients came together to fuel a severe line of thunderstorms that we had last night, to where tonight we've got a front coming in and it almost looks like it's the same setup. You got a front coming in, so you have that energy aloft. It's really warm today, it's really sunny, so why aren't we going to get storms that are going to become severe? We just don't have that humidity level like we had yesterday, and the winds are a little different too. So everything is totally different, even though it seems like on the surface the forecast is about the same. Behind the scenes, there's a lot that is changing. So every single day is a little bit different, and that's what I like. I love, is annoying as it can be when the weather changes a lot, those are fun times, I think, not only for myself, but for a lot of us, because it's changing weather. We get to explain what's happening, and it makes it interesting, and it gives it, that weather story becomes a lot more interesting to tell. So I like it when there are changes and things are moving around. I would not want to be a forecaster or a meteorologist in, say, San Diego, California. Love California, beautiful state. Love the sunshine and the weather and all the topography and the mountains and everything that goes on there. It's a wonderful spot. But sometimes the weather is just too calm in a spot like that. Hawaii is another spot, one of the most beautiful places in the country and in the world for that matter, but yet the weather doesn't change a whole lot there. They do have some changes. It is interesting at times, but I like it here where we've got 4 seasons, and just look at the forecast from today into tomorrow. We go from maybe a sprinkle or a snow flurry later tomorrow and strong winds and cold, and today it is absolutely stunning and beautiful, and that's all going to happen, all those changes happening in a matter of hours. So a good question there. Can a human fit inside a weather balloon? So do not try this at home. Courtney asking this. You do not want to try that at home. I can't fit into this right now, but when this thing blows up, like we were showing you on that video, it is almost the size of a person. So if the balloon were to pop, and it would pop if you would have a big enough opening to try to fit in this thing, then in theory you could get into it. And by the time that balloon rises up into the sky, it gets bigger and bigger and bigger. You could probably get more than 1 human in that balloon, the size that it gets. Easily could do so as it gets really big. Okay, good question. So Shannon, this is an interesting question. If there is a hailstorm, does the hail pop the ball, or I assume does it pop the balloon? So yeah, it can, and sometimes this happens. And this is where things get tricky, because these balloons are supposed to go up at certain times every single day. But there are times where the weather is not very kind to those forecasters that are trying to launch the balloon. You know what? I tell you, if you get an opportunity to look, I know there are some videos, I think, on YouTube. I'm afraid it would take me too much time to do it right now. But, with Mom or Dad's help, you could probably look this up. But look up weather balloon launch in blizzard. I think that's one. I think those keywords will get you to where you want to go. And those poor forecasters are out there. This balloon's whipping all over the place, and they're just trying to keep it stable. And I think in that case it popped, maybe not, but they're trying to keep it. They're trying to get out of that building quick enough to where the balloon doesn't blow back and hit the edge of the building or the edge of that metal to where it pops the balloon. And when I was up at the Detroit Weather Service office, they were saying the same thing, that in some of those big storms that we had 5 years ago during our record snow year that we had, they had a big problem. I think they had like a couple balloons pop, and it took them a long time, almost an hour, to be able to get that balloon actually up and successful on that particular day. So yeah, sometimes things like that happen. They'll try to launch the balloon if they can, but occasionally it doesn't work out. There's also times where if severe weather is expected, they may launch 3 balloons in a day, not 2, because they want to get a better idea of how much instability is there, and that can be really important to a severe weather forecast. And I'll usually do that early afternoon in that situation. So good question there. So Walter asking, we don't have a dry front in this area, question mark. No, we don't. And so if when we talk about a cold front, that's the boundary between cold air and warmer air. And cold air it's cold and it's dense, and so it's heavier air. And so as that comes in, that cold air is going to sink right to the surface, and that cold front usually picks up steam and some movement to it. Warm front is a little different. The warm air is less dense, so it overrides the cold air and produces clouds and rain and snow and ice, and when we get that scenario. Dry line is a totally different, so it's you call it dry front, dry line. It's really the same thing. Dry lines take place typically out in western Texas, western Oklahoma, but they can be as far as about the Arkansas, Oklahoma border. We've seen it that far to the east when I was out working in Arkansas several years ago. It could be back into New Mexico, and that happens a lot of times in the summertime. Here's the thing about those dry lines is they don't really move at all from where they're at. They move to the east somewhat during the day a little bit, and then they retreat and usually go back to the west. And so those storms that fire up on the dry line are much different than they happen here. Usually you have better visibility because you have dry air surrounding some of these storms, and so you can see these lightning storms from far away. You can see the severe weather develop much easier, and the storms like to seem to fire off in a similar spot. And that's one of the reasons why Oklahoma City is the bullseye for severe weather around the country. Not only do they have warm fronts like we've got, not only do they have cold fronts, not only do they have storm systems and really ripe ingredients a lot of the time, but they've got a dry line that just kind of hangs out there. And that's a boundary between the hot, dry desert air out in the southwest and the really warm, moist air coming off of the Gulf of Mexico. So that has a tremendous impact on severe weather out into Texas, Oklahoma, and Kansas, even Nebraska out that way. How long does the ball stay up for? So I'm going to assume we're talking about the weather balloon here. The weather balloon will stay up as long. The weather balloon will typically stay up, I think it's like 25, 30 minutes or something like that on average. It just depends. Sometimes they pop a little too quickly. Sometimes that if they run into something or if the balloon isn't as strong, sometimes they'll go much farther away. Sometimes they travel all over the place in that span if the winds are really strong. So it does vary, but I believe it's about a half hour or so. And that data comes back almost in real time on a computer screen that they get to look at. Let's see, any other questions here? What happens if Shannon asking, what happens if the tools don't work? So if our weather tools don't work, we have to do the best we can do. Usually they don't all fail at the same time. So weather balloons, occasionally one of them doesn't work. There's usually enough weather data to fill that in. It's not too big of a problem. I've had situations where I've come in and the temperature network is down. It's annoying, but we can kind of get around it. We've got some instruments here too. We can get an idea what's happening. Usually there's some workarounds. I had a situation this morning where I came in and one of my plots that I look at for the computer models, that actually what it's doing is it's not taking one computer model, it's taking a lot of computer model data together, and it's showing me the trends of where they're at. So I have an idea of, are they all agreeing or are they pretty far apart? And if they are, what are those ranges? And so it's a tool I look at every single day because it's looking at multiple computer models all at the same time. And that wasn't updating. And I wasn't real happy with it, but I just looked at the data in other places and kind of filled in the gaps as I go. So it does happen. Thankfully, usually we're not looking at like an outage of all of our weather forecasting tools at the same time. It definitely happens. Again, it's technology, and just like as we all know, technology doesn't always work out too well for us. So Courtney asking, what state has the best computer model? The computer models that we have are usually organized by countries, not states. So there are different universities that will maybe have websites that'll have computer models on it, but all of that data and all of the computer modeling code is generally coming from the National Weather Service and a special department that's looking at all this. And all that data, again, just like we talked about the radar data the other day, that with that $1 that the average American pays in their taxes, that funds the National Weather Service, the radars, and all that data, that is available to anybody. That's why you can go on and look at those computer models whenever you want. But those different computer models that are options there you're looking at the United States computer models that they have. And some of them are really good for severe weather. Others are much better for looking out long term. They all have their points where they're good, and in some cases they're not so good times. Now, different countries have different computer models. So when we're looking out, we've got a long range one for the United States. Canada has a long range one. Japan has a long range one, but we don't look at that one too often. And Europe in general, the European Union essentially, all those countries that come together, has a computer model also. Why would we want to look at a computer model that Japan or Canada or Europe has? Because they're what we call global models, and they cover the entire globe at the same time. And actually, the European model is one of the best computer models out there for looking long range. The computer model I showed you yesterday with the storms for the severe weather that did a really good job, that's probably our best severe weather computer model that we've got, and that's a United States one. The United States has got a great one that is the GFS, which does a pretty good job with the European one too. So all of them, you generally have their points where they're good and then sometimes not so good things about it. Let's see here. Okay, so Dean's asking, and for those that are still watching here, I'm going to turn the camera around to try to give you a better explanation of what Dean is talking about here. Dean goes, how do you know where you are pointing with the green screen behind you? Is it on a monitor in front of you? Thanks, stay safe and well to all there. All right, Dean, so hopefully, let's see what I can do here. Let me go back. And let's see. Nope, I'm not going to be able to do that. All right, so I'm going to do the best I can with this monitor. So there's our green wall, and so yeah, it looks like I can't pull. It looks like I cannot expand this at this point. But let me see if I can draw on it on this little box here and kind of show you what's going on. So we've got this spot right here. Oh, does not want me to draw on it, it looks like. Okay, here we go. All right, so this little spot, that's not working either. Oh, it does not. This tool says, no, you are not going to point on that box at all. All right, great. So it's kind of hard to point it out. But that little spot that's kind of right to the right of the green screen where it's kind of a black box there, what that actually is, and here's what I'm going to do, Dean. Maybe next week, remind me if I don't do it next week, but I'm going to show you this green wall. We'll break it down even more for you at that point. Because I'll be able to get a lot closer, or maybe I'll even walk over there and just kind of walk you through it. But that box there, that is a monitor, and there is actually a small camera right above it. And so when I'm looking at the camera, I'm actually looking into a monitor so I can see where I'm pointing there. And then on the sides of the green wall, there is a monitor on both sides. It's a really large green wall. We could probably get more than one person in there. Generally, there's just one of us, though. And you could see where you're pointing at by looking at either of those monitors. So when you point towards the green wall, while it looks like I'm looking at the green wall or the weather graphics, I'm actually looking at the monitor. So that's kind of the secret to that. But one of these days, that's a good question. I think there'll be a lot of other people that are wondering the same thing. And at some point, I'll be able to take that little camera image and blow it up, or maybe you'll be able to walk over there all together with it. So good questions there, and make sure to take those observations, write them down, take a picture of them, have your mom or dad send them to me, whether it be on my Facebook page or as a comment coming up next week. There's several different ways of doing it, but I'd love to see them, and excited about that. And next week we'll learn more about clouds, fronts, and how to forecast weather.